Okay, so inequalities. Inequalities are probably a little bit more common even than equalities when you're talking about making up math models, right? When you're deciding to go to a store to buy something, what you typically do is you set a budget for yourself that you want to spend $200 or less. You know, that's an inequality. You're not looking so much that you want to spend $200. That's the same thing when you're looking for a job. You have certain expectations for your income that you want to be paid, you know, this amount of money per month or more. You're not going to object if it's more. And so we kind of live more in the realm of inequalities. So when we solve an inequality, what we do isn't finding a particular number as much as we're finding a solution set, so that there's generally more than one value that makes that inequality true. So the first thing we'll do is we'll look at some notation. Now we have like 4 different cases if x has to be between 2 numbers. One of them is when x can be equal to or greater than a and less than or equal to b, or on one side or the other you just have the inequality without the equality part of it. And so all of this stuff makes sense. You have to be greater than a number, not equaling that number, up to a number, but you may include that number. And so if you look at it from a graphical standpoint, we have a fairly straightforward way to represent this. When we're talking about the equality, we use the square bracket. Okay, so that first one says we're going to go from A to B and we can include A and B. The second one here says that we're going to go from A to B, but we're not going to include A. It's all the way up to A, as close to A as you want to get, just not A. And you're going to go up to B and include that. So any of the combinations are possible, that you have maybe the third case where it can't be either equal to A or B, or it can equal one or the other. So not a stretch of the imagination, I don't think, but certainly we have those cases to deal with. Now when we're writing the solution to this, probably the more common way to write it is we write an interval. And so we use the same symbol for the bracket. We either use a parentheses if we're not including that number. We use a square bracket if we include the number. So in that first one, you're including both A and B. If you look at the third one, we're not including either A or B, but every number in between the two. Unfortunately, this is a little ambiguous in some cases, because if we're looking at a two-dimensional plot, in parentheses, that could be a point on a two-dimensional plot, right? A coordinate pair. So you have to be fairly clear in the context of using these, whether you mean an interval or a point, you know, an XY point or something of that sort. And if we're working on linear equations with one variable, it generally follows pretty readily that we're just talking about an interval. But if there's any ambiguity, you might want to make some sort of notation that that is actually the interval, or that you're answering in an interval notation or so. Now there's a different way to represent this, and it's excuse me, it's what's called set builder notation. And set builder notation looks complicated, but it's actually fairly straightforward. You start out with a statement with the bracket, or the brace, I should say, and what that means is the set of, and then you throw in the variable x, and then that vertical line means such that. So if you read this just the way you would like a sentence, you say the set of x such that x is between A and B. So the key to this is starting off with the brace, put your variable, put the such that symbol, and then any expression that you want can go in there. There's nothing, you know, particularly difficult about this. If you want to exclude a value, like you say every number is possible except 3, then you would write the set of x such that x does not equal 3, and then close your brace. So I would try using this fairly regularly. It's a common notation. It looks more sophisticated and more difficult than it really is. It's just those 3 symbols are kind of the start to it, and then you put your expression in. And sometimes it's a little more clear than interval notation, because there you're really saying it's a set and there's no ambiguity whatsoever. Now, oftentimes we just have one-sided inequalities, like A is less than X, or A is less than or equal to X, or B, or whatever. And so on a number line, what we do is we use the same symbol for whether we're including A or B, and then we just run the line off to whatever direction the inequality is pointing to. So the first one says that X can be anything greater than A, but not including A, so we use the parentheses and we make the notation that way. And so you can see the other three, you can use the combination of, or you can use your choice of either the parentheses or the square bracket. When we're writing these as intervals, though, we need to write an endpoint, and there is no endpoint to these. So what we use is a symbol for infinity. That's that sideways 8, okay? When we're going from A all the way up to infinity, you write the infinity, and notice you always use the parentheses with infinity. That's because infinity is not a number, and so you are never reaching infinity, and so it's really truly open-ended. So whether you have a parentheses or square bracket on the side with the real number, the other side always has an infinity with a parentheses. Now, if you're going the other way, if you're going to the left, where you get progressively smaller and you go, down to negative numbers without bound, we talk about that as being negative infinity. So remember, though, that these are concepts and not numbers. We talk about negative infinity and positive infinity. We're really talking about how do these numbers increase or decrease without bound, is what it really means. So if you want to talk about all real numbers, you write from negative infinity to infinity. So there's another way. Remember, we were using that funny-looking R as the set of real numbers. That's a perfectly good symbol. This is a perfectly good symbol as well. Okay, so sketching graphs here. If we have these statements, I'll give you just a moment and just write those in your notebook. You should see them. I'll show them to you in just a moment, but why don't you just take a step ahead of me and write what those graphs look like on the number line. Okay, let's see what we have here. So I'll make 3 number lines, and then the first one, I put a square bracket. The second one is also a square bracket because that's less than or equal to -3. And then the third one, since we have the less than or equal to, and then we have the inequality, the less than without the equal, you use a mix of the square bracket and the parentheses. All right, now, since we have intervals, we want to talk about the lengths of intervals and how to calculate them. And we're going to get to the point where, with our absolute values in inequalities, the length has a special meaning when we're using absolute values. But we can still talk about lengths in terms of these intervals. And so what you want to do when you're calculating the length of the interval is basically just take the larger number and subtract the smaller number from it. So if we look in the first case, pretty straightforward. 10 minus 4 is 6. Second case, 13 minus 5 is 8. Third case, 7 minus 0 is 7. So if we were to graph those and we would measure along our axes, that's how long they would be. Notice there's no difference between the square bracket and the parentheses. So when we talk about interval lengths, it really doesn't matter if that last point is included because we can measure as close to that point as we want, and ultimately that's kind of its limiting value, or where you go up to that number, just not including it. Now the last one, you see the larger number is 4, the smaller number is -2. Still take the difference of it. Don't take 4 minus 2. You want to take 4 minus a negative 2, which makes that 4 plus 2, which is a 6. Oops, that's a little fast, I know. Sorry about that. Now, once we get to absolute values, we're going to put absolute values around here, and then it doesn't matter if we put the larger one in, first minus the smaller one. But for now, we're looking at this as, you know, the larger one minus the smaller one. So the properties of inequalities, these are mostly the same as the properties of equalities that we have, like the first one here, where you say, okay, if A is less than B, then if we either add something the same to both sides or subtract the thing from the both sides, you still maintain the inequality. So in other words, if I say 2 is less than 5, if I add 1 to both of those, so I get 2 plus 1 is 3, and then 5 plus 1 is 6, I still have 3 is less than 6. So we can add or subtract from both sides, and we maintain that inequality. Now with multiplication, we have to pay attention to what is the sign of the C, this thing that we're going to multiply by both sides. So if A is less than B, and we're talking about a positive number C, then the inequality holds just the same. So in my example of, let's say, 2 is less than 5, if I multiply both of them by 3, I get 2 times 3 is 6, and then 5 times 3 is 15. So it's true that 6 is still less than 15. And the same thing holds for division. Now there's one little property in here. We call this the transitive property, and the name of it isn't important. It's just the concept here that when you have one thing that's smaller than another, that these inequalities propagate through. So let's say if I'm taller than my sister, so my sister is A and I'm B, okay, so her height is less than me, and then my older brother is taller than me, so C is greater than B, then you conclude that my older brother is taller than my sister, right? She would have to be. And so that's all this transitive property means, is that we want to keep the inequality sign going the same way as we're talking about these things, so we get this nice orderly progression of sizes. All right, let's go back to this case where we have C is not greater than 0. Let me take a real simple one and use the first property where I'm going to add the same thing or subtract the same thing from both sides. So on the left, on the green side, I'm going to subtract 3 from both sides, and I get x is less than negative 3. All right, I'm finished there. If I do it the other way around, if I say I'm going to subtract x from both sides, then I get 3 is less than negative x. And so if I turn that around to say negative x is greater than 3, you see what happened when you compare those two. Both of those were valid, but when you multiply both sides by negative 1, you've got to change around that inequality. And so that's the place that you have to be very careful. Now notice, well, let me write the statement here first. If C is less than 0 and A is less than B, then AC is greater than BC, and A over C is greater than B over C. Now probably the best thing to do is show you an example, and I'll write it on the board. If I have negative 3 is less than x, which is less than 5, I'm going to, actually let me make this a negative x, okay? If I multiply this all the way through by negative 1, I'm going to get 3 is greater than x, which is greater than negative 5. This is a compound inequality, and we'll get to them, but this is the kind of thing that I'm talking about, that when you multiply through by a negative number, you're going to change the sign. Okay, so let's solve this one. This is a fairly straightforward one. See if you can work ahead of me a little bit here. Okay, what do you expect the solution to this to be? Okay. Subtract 3 from both sides and simplify, and you get x is less than negative 1. X is less than 1, not negative 1. Okay, so we'll put that in interval notation as negative infinity to 1. And notice I don't include the 1 because it's x is less than 1. So any number less than 1 fits in there. So if I say negative 2 is certainly less than 1, so negative 2 plus 3 is going to be 1. 1 is less than 4, so we're true in that case. Okay, let me try a different one. We'll get a little bit more complicated as we go along. Now, when you have x on both sides of the inequality, you can avoid this whole issue of multiplying by negative 1 if you anticipate which side will give you the positive x. And on this side, you see the 3x is greater than the 2x. So if you move the x's over to the left, you're going to end up with a positive term in x. And so first thing I'm going to do is move the 7 over by subtracting 7 from both sides. And so I get 3x is less than 2x minus 8. And then I'm going to subtract 2x from both sides. And so I get 3x minus 2x is x, and then 2x minus 8 minus 2x is just negative 8. And so there's my solution. 8 is less than or x is less than negative 8. So I didn't put that one in interval notation, but it's similar to the one that we just had, where it's going to be negative infinity, comma, negative 8, and then close with a parentheses. So why don't you try this one? And so what I get then is 7 is less than or equal to x. Now, did you move the 5 over to the right side? Is that how you worked it?
I started by, because I noticed there was a negative x, so I just multiplied by negative 1.
All the way through?
All the way through, and moved the 5 over.
Okay, so then you have negative 5 plus x is less than or is greater than or equal to 2, and then you brought the 5 over, and you got x is greater than or equal to 7. Perfectly good. Yes?
I did it minus 5 from the right side.
Yeah, if you subtract 5 from the right side, then you get negative x is less than negative 7.
Yeah.
And then you multiply by negative 1, so you get x is greater than or equal to 7.
Switches it around.
Yeah.
What does it do that? Does it always do that if it's a negative?
Well, you want to solve for x, and so anytime you want to make your a negative x into an x, you multiply by negative 1, and that's when that happens. And for these linear equations, that's generally the time that it occurs, is when you're trying to change the sign of the term that involves x. All right, here's another one. Hope you can read that. That's 4 times 4 minus z is greater than or equal to 8 times 1 plus z. So that one has a perfectly good solution. Anything less than 0 works in there. And so we'll move on. Okay, so I showed you a glimpse of a double inequality a few minutes ago. And what these double inequalities are is when we have kind of an order of something smaller to something in the middle to something that's greater. So we have negative 3 is less than or equal to x plus 2 is less than 6. And so the way you solve these is exactly the same as you do the other ones, only you really don't have a choice of going to the left side or going to the right side. What you want to do is remove everything possible from the middle except your variable. And so this one, we're just going to subtract 2 from every part, and so we find that we have negative 5 is less than or equal to x, which is less than or equal to 4. Now you should check that your inequality signs all go in the same direction, and that it must be true that negative 5 is less than 4, because that's what you're suggesting. Just like my sister is shorter than my older brother, that kind of order has to happen. So if we look at one that's slightly more complicated, here we have a negative 10 is less than or equal to 4 minus 7x is less than 10. So we know that at least it should be possible because we have negative 10 is less than 10. And so first thing we're going to do is probably subtract 4 here. And then simplify that. And so we get negative 14 is less than or equal to negative 7x, which is less than 6. And I think I pushed my button twice, but anyway, we have, look at the third line from the bottom. You see we have that negative 14 over 7, and it should be negative 14 over negative 7. Let me correct that. Okay, I made that in green, but that's okay. So I have that situation. What I need to do now is divide through by negative 1. And so if I, did I even do this one right?
You switch the signs?
Oh, you know what I did? Here, I'm wrong here. I did do it right. What I did was I just divided by 6 before I did anything, or by 7. So I have negative 14/7 is less than or equal to negative x, which is less than 6/7. And then what I did was I multiplied through by negative 1. And so instead of negative 14/7, I have 2, which is greater than x, which is greater than negative 6/7. That was the step, since I multiplied by negative 1, that my inequalities changed the direction. Now, that's a perfectly good answer, but it's a little, I think, more readable if you put it from smallest to greatest. So if we say negative 6/7 is less than x, which is less than or equal to 2, that's the easier way to read it. And certainly the line above it isn't wrong. It's factually true, and it makes mathematical sense. But the last one is really probably the preferred answer. Yes?
I divided by negative 7.
Yes?
And then how does that keep the x to still be negative? How is it still negative after you divide the negative 7 all three?
Yeah, and that's what I was confused about in my own work. Let's say we were at this step where we have negative 14 is less than or equal to negative 7x, which is less than 6. Now, if you divide through by negative 7, what you get is these values, but you have to decide where these go. Since you're dividing by a negative number, these go then this way, like that. And so 14/7 with a double negative just makes 2 is greater than or equal to x, which is greater than negative 6/7, and we're at the same place. All right, oops. Boy, I really went too far. Okay, I'd like you to try this one. It follows the pattern fairly closely, so you can refer to it step by step or take your own path if that works out better for you. All right, so we'll subtract 4 from every line, or every segment of that, and then we get negative 10 is less than or equal to, oh boy, I'm just not doing this very well today. Okay, so we end up with negative 10 is less than or equal to negative 2x is less than 4. So we'll divide through by negative 2, and so that's the event that makes us change the direction of the inequalities. And so then that negative 10 over negative 2 becomes 5 is greater than or equal to x, which is greater than negative 2. And so if I rewrite that in an ascending order, we have negative 2 is less than x, which is less than negative 5. Less than or equal to 5, not negative 5. Yes?
Can you just explain real quick, why you switch the, quality sign when you divide by negative number?
Sure. You do that in order to keep things consistent, okay? So let me just put up two numbers here. If I have x is less than -1, all right? So let me move the x over to this side and move the -1 just by addition, okay? So I'm going to say x minus x is less than -1 minus x, and so this becomes 0, is less than -1 minus x. And so then, if I add 1 to both sides, I get 1 is less than -x. So let me turn this around now, where this is the larger one, that's the smaller one. We have -x is greater than 1, and compare it to this. So if I were to multiply this by -1, I'd get -x. This by -1, I'd get 1. But I would have to switch this around in order to agree with this. Okay, so we do it for consistency. The other way that you can think about it is that if everything starts from 0, you go off to the right for larger numbers, go off to the left for smaller numbers. And so if you have 4 is greater than 0, if we multiply all that by -1, I get -4 is less than 0. Okay, so you change the sign there. Yes?
Can you write it, I wrote it like the opposite way, like 5 is,
The one right above it, the 5 is greater than or equal to x, which is greater than -2?
yeah.
Yeah, it means the same thing. I think just from the standpoint of trying to, when you're reading it for understanding, I always think it's easier to go from the smallest to the largest, but there's no rule that says that. It's certainly not mathematically incorrect to write the one above it. It's just you have to stop and think to yourself what's going on. The thing that is important, though, is that it all makes sense, that we have -2 is less than x, which is less than 5. So what it's suggesting is that 2 is less than 5, which is true. Okay, so here's what we're going to call compound inequalities. And what a compound inequality is where you have two inequalities and they're separated by the word either and or. And so a typical problem there may be something like 2x minus 4 is less than 4 and 2x plus 8 is greater than 6. The key thing to know about the word and is that both of them must be true. If I ask everybody in this room with brown hair and blue eyes to stand up, those of you with brown hair and brown eyes wouldn't stand up, right? When I say and, I mean both criteria have to happen. If you just had blue eyes, you wouldn't stand up. But if I said or, if you have brown hair or blue eyes, then you'd have people that had one or the other and both. So the words and or have a different meaning, where and both statements have to be true. So we're going to solve this, and we're going to realize here that I'm going to find some relationship or some statement about the value of x, and it has to be consistent. Okay, so I'm going to solve the one on the left first by adding 4 to both sides, and then divide by 2, and I get this thing that says x is less than or equal to 4. Okay, so that's from the left-hand inequality. Then the right-hand one, I'm going to solve that, subtract 8, and then what I get is x is greater than -1. Now, is it possible for x to be both less than 4 and greater than -1? Certainly is, right? We can write it like this. So long as x is between -1 and 4, we have a solution. Now, you don't always have a solution. So here's a case where I have another and, where you have 2x plus 1 is greater than 3 and x plus 5 is less than 2. So I'll go through the same process of solving for both sides. And on the left side, you see I added or I subtracted 1 from both sides, and I divided by 2, and I got x is greater than 1. On the right side, I subtracted 5 from both sides, and I get x is less than negative 3. That can't be true, right? You can't be more than 1 and less than negative 3. So in this case, we have no solution. Even though it looks like we have perfectly valid algebraic expressions. Now, if we change that word to or, okay, the equations are the same, or the inequalities are the same, and I get x is greater than 1 or x is less than negative 3. By or, I'm okay. I certainly can be one or the other. I don't have to be both at the same time. So I have that U in there, which means union, which is the same thing as or. Now, if I want to have the equivalent symbol, what I would use is an upside down U, and what this means is and. And so what we call this is the intersection. And U, it means or it's the union. Now there's, the way that I remember this is that U stands for union, which is easy enough to remember. This upside down U, if you cross it, you get an A, okay? And that's the way I remember it. That means and. And so you know a union is this, so the other one, the intersection, must be that. And you know the and is this, so you know the other one, the or, must be the union. And so make a note of that, and you want to keep track of which one is which. And so we use these to join intervals, either say or we can say and. Okay, so that's basically it. Let's look at an application here. So you have a perimeter of a rectangle, and you want to make this between 30 and 42 centimeters. You know the length of the rectangle is 12 centimeters. What is the width? Okay, since you want to be between two numbers, you're going to get an interval, right? There's going to be a set of solutions, not one particular solution. So go ahead, set this up as an inequality, and then we'll talk about what you get. Okay, so we're looking for the width, and so that's the first variable that we want to define. W equals the width. And then we have to know what the perimeter is, or we have to know what the definition of a perimeter. And so basically it's the sum of all the sides. And so the perimeter is 2 times 12, because the length is 12, and then it's 2 times W, which is the width. And so we can simplify that 2 times 12 into 24, and just write our perimeter as 24 plus 2W is going to be the perimeter. So then what the problem is asking us is we want the perimeter to be between 30 and 42. Now here I just put the inequality. Now depending on the context, certainly if you're doing this to figure out the dimensions of a box that you can ship or something like that, you would put the equality part of it. So it's really dependent on what the model you're using, whether it's important that you can equal 32 and 42 or that you shouldn't equal 30 and 42. Okay, so I join these two with an and so it has to be greater than 30 or less than 42. And so if I just basically solve these, the first one, what I do is I subtract 24 from both sides, and I get 2W is greater than 6. And then I divide both sides by 2, and I get W is greater than 3. On the right-hand side, I do the same thing. Subtract 24 from both sides, and I get 2W is less than 18. Divide by 2, and I get W is less than 9. Very often with these kinds of inequalities where you're looking for a range of things, that it's easy to put it into a notation where you have it has to be greater than and less than. So we have a greater than 3 and a less than 9 on here. Okay, any questions on this one? Did I make any mistake?
What would be the final answer though? Like it's just between them, like between those two numbers?
Here's the answer. The width should be between 3 and 9. Okay, so we're just looking for the value of the width, and so you need to be between 3 and 9. So if you're at 3, then 3 plus 12 plus 3 plus 12, the perimeter is 30. And if you're at 9, then 9 plus 12 plus 9 plus 12 is 42. So you need to be between these. Does that answer your question okay? Okay, so there's really not too different of a strategy in solving these. It's basically setting up the inequality to represent what the words say. All right?
I have a question.
Yeah.
For the, like 24 plus 2W,
Mm-hmm.
why is the inequality like facing away from 30, and then another one is facing 42?
Yeah, so the first one, the 24 plus 2W is greater than 30, means that we want the perimeter bigger than 30, right? So that's going to be bigger than. The second one is that we want it to be less than 42, and it has to be both, so we use an and.